The box girder manufacturing process in China is a high-precision and fast engineering show for large infrastructure projects. It all starts with the preparation of giant steel molds. Then, pre-bent reinforcements are placed in these molds, and high-strength concrete is poured with pumps to create a hollow, solid box form. After the concrete is poured, these giant structures are kept in steam, curing chambers to harden quickly. Then the molds are dismantled, and each beam is checked with measurement systems, and the surface is smoothed and deburred. These giant pieces weighing tons are taken to the transportation area by cranes over rail systems and loaded onto trucks or special carrier systems to be transported to bridge or viaduct sites. In China's mega projects, this production line works almost continuously. Dozens of box girders are produced with millimeter precision every day and made ready for shipment. This process is a huge production operation that requires heavy engineering, speed, and perfection. Box girder production in China is a high-precision and fast engineering process. First, steel molds are prepared, reinforcement is placed inside, and high-strength concrete is poured to obtain the box form. The concrete is hardened in steam-curing chambers, then the molds are removed, the beams are checked, and their surfaces are smoothed. Bridge construction in China is a perfect combination of engineering and speed. It all starts with excavating solid foundations, then building huge concrete piers and towers. Steel or reinforced concrete beams are placed by cranes and connected with millimeter welds. Prefabricated parts speed up the assembly process and minimize time loss on site. Once the cable, deck, asphalt, and railing installations are complete, the resulting structure becomes a transportation marvel that is both durable and impressive. Everything starts with the transportation of the giant parts of the TBM to the construction site. The parts are carefully placed in the assembly area with cranes and assembled. The cutter head, main body, conveyor system, and support units are assembled in order. Then the system carrying the concrete lining segments is prepared, and all power, ventilation, and guidance equipment is connected. After the TBM is placed in the starting room on the rail system, it is ready for the first drilling. This giant machine is tested with millimeter calibrations before entering the underground. When it is ready, it moves forward and starts digging the tunnel deep underground. Once the installation is complete, the TBM starts working like a giant factory on its own. Saren's Boiler Modules is a special heavy lifting and transport operation used for the transportation and installation of the huge boiler parts that form the heart of giant power plants. Each module is positioned with centimeter precision and then fixed in place. This system, which is usually used in energy, petrochemical, or large industrial plants, ensures that the basic components of the plant are installed quickly and safely. Thanks to Saren's expertise, these multi-ton structural elements are placed without any problems, even in difficult field conditions. These operations are a true demonstration of heavy engineering and coordination. Rotational bridge construction method, i.e. the bridge construction by rotation method, is an extraordinary engineering technique designed to have minimum impact on both time and traffic. In this method, the main span of the bridge is constructed parallel to the ground in an area close to the construction site. Then, the bridge platform is slowly rotated around its own axis on the horizontal axis with the help of specially placed rotary joints or hydraulic systems and brought to its final position. This method, which is generally preferred in areas requiring uninterrupted transportation such as railways or highways, is much faster than classical construction methods and has minimum impact on traffic. While the process can be completed in just a few hours, structural integrity is not compromised thanks to prefabricated elements. Once the rotation process is complete, the bridge is fixed to the support points and is ready for use. This method is one of the most impressive bridge construction techniques in which engineering works by bending time. Maxim Crane Works played a pivotal role in constructing the Mercedes-Benz Stadium in Atlanta, Georgia, particularly in handling the complex lifts required for its iconic retractable roof. The stadium, featuring a 14.5-acre oval-shaped retractable roof, demanded precise and heavy lifting operations. To meet these challenges, Maxim Crane deployed a fleet of 24 cranes, including 12 conventional crawler cranes, an all-terrain crane, 4 hydraulic truck cranes, 6 rough terrain cranes, and a boom truck.
Imagine, instead of giant concrete blocks, your house is being produced layer by layer by a 3D printer. Yes, you heard right. Thanks to this technology, the walls of a house rise in just hours. Chinese engineers are using this tremendous technology, breaking new ground in the construction industry, and are astonishing the world with their clever designs. UPV construction is an innovative technique that radically speeds up the construction process of modular structures. Prefabricated modules are brought to the construction site and assembled like Lego pieces. But we are not talking about an ordinary process here. There is incredible coordination, precision, and technology behind the work. Imagine a perfect engineering product used from the foundation to the facade of a building. Structawire is an innovative reinforcement technology that surpasses standard wire mesh systems used in construction. These wire meshes are both lightweight and incredibly durable. When these features are combined with the unique mastery of Chinese workers, the result is astonishing structures. Umbrella Tiles Row, as its name suggests, represents a technology far beyond ordinary tiles. This innovative roof system makes a difference in both aesthetics and functionality. So, how are these tiles so special? Here are the surprising details. These tiles protect all areas under the roof by directing rainwater like an umbrella. This feature offers a revolutionary solution in waterproofing. Cobra Flexible stands out as a flexible yet incredibly strong building material. So what makes this technology special? Think about it. A material that is resistant to impacts and extreme stresses, while also preventing damage by stretching when necessary. Used in many projects from bridges to skyscrapers, this system is revolutionizing the construction industry. Lyre Durasol is an ultra-durable and environmentally friendly coating material. This material not only beautifies the exterior of buildings, but also provides incredible protection. Whether it is the scorching heat of the sun, freezing cold, or heavy rainfall, Lyre Durasol is resistant to all weather conditions and looks like the first day for years to come. The most striking feature of Lightcast XT is its low weight and incredibly high strength. This feature offers a revolutionary solution especially in high-rise buildings, bridges, and wide-span structures. Used instead of traditional concrete blocks, Lightcast XT speeds up the construction process and significantly reduces transportation costs. What is Dry-in-Base and why is it so impressive? This technology offers a perfect solution for water control and drainage systems, especially in infrastructure projects. Used instead of ordinary concrete bases, Dry-in-Base stands out as a system that manages water drainage quickly and effectively. In this way, it both minimizes the risk of flooding and adds extra durability to the infrastructure of the structures. What is Gripple Fast Track? This system is a technology that allows quick and easy assembly of suspension and support elements. Assembly processes that would take hours with traditional methods are completed in minutes thanks to Gripple Fast Track. Moreover, it offers a lighter and more convenient solution without the need for heavy and complex equipment. What makes Patterson Shoring so impressive? First, the system is incredibly fast to install. A job that would take days with traditional methods can be completed in a few hours with this technology. Second, it increases work safety thanks to its high durability. Keeping large and complex structures stable during excavation and foundation processes is now much easier with this system. Radirock is a large-scale, durable concrete block system. These blocks provide incredible results in retaining walls, bridge supports, and ground stabilization. But you should quickly understand that Radirock is not your average concrete system. Thanks to its modular design, these blocks can be easily assembled like Legos, creating a solid structure. Wall insulation system is a superior technology designed for thermal insulation, soundproofing, and structural durability. The system consists of lightweight but effective insulation panels placed inside the walls. These panels provide excellent protection against external factors. It keeps your home cool on hot summer days and offers a warm environment on cold winter nights. This innovative system is a connection solution used in furniture and staircase assembly. Unlike traditional fasteners, ZipBolt works with millimeter precision, allowing you to complete assembly operations incredibly quickly. This technology, which makes the screwing process effortless, is a savior, especially for workers working in cramped spaces. Dinsel installation is a system that allows fast and effective construction of structures using modular wall panels. These panels are incredibly durable despite their lightweight. It offers an ideal solution especially for high-rise buildings, infrastructure projects, and commercial structures. This innovative method is a technology that allows structures to be built quickly and safely using lightweight but extremely durable metal panels and pipe systems. This system, made with strong materials such as aluminum and steel, provides incredible results, especially in infrastructure projects, high-rise buildings, and industrial facilities. Prepare to hold your breath as you watch Exchange 106 rise. It's one of the most stunning feats of engineering in Malaysia and even the world. Now, we're diving into the construction side of this 106-story giant. The secret lies in the massive hydraulic climbing systems that hold up the skyscraper. The super strong tower cranes are the stars of the show. They lift hundreds of tons of weight into the air at a time, placing the steel columns in precise position. Meters above, the steel workers meticulously secure each piece, while the machines never stop. Jeddah Tower is one of humanity's biggest steps into the sky. This giant, which will reach 1,000 meters in height, is rising to claim the title of the world's tallest building. So, is it possible to build such an incredible structure? Here is the answer: giant machines and engineering that pushes the limits. This is not just a building, it is an engineering marvel. Standing at 541 meters high, One World Trade Center is one of the most iconic skyscrapers not only in New York but in the entire world. But how is this giant built? Here is the story of the rise of the steel monster reaching into the sky. An engineering marvel rising above the waves. The Noryang Bridge is a giant transportation masterpiece built in South Korea's harshest natural conditions. But building such a long and strong bridge over the sea, it's an engineering challenge. It all starts with the raw material feeding systems. Cement, sand, gravel, and water are transported by huge conveyor belts and directed to Mexpress's high-speed mixers. This is where the crazy mixing process begins. The giant mixing arms transform the materials into a homogeneous concrete mixture in seconds. It all started with huge foundation excavations. Reinforced concrete piling machines placed piles that went down meters deep to create a solid ground that would carry the giant structure of the stadium. Tons of steel and concrete were poured with millimeter calculations to support the huge loads. One of the greatest stages in football history. The Lusail Iconic Stadium is one of the most modern and gigantic stadiums not only in Qatar but in the entire world. But how was such a huge structure built in the scorching desert heat? Here is an incredible construction process that pushed the boundaries of engineering. Basement excavation is a huge excavation process to create a solid foundation underground. Hydraulic excavators lift tons of soil, while trucks and conveyor systems quickly evacuate the excavation. But the biggest risk is the collapse of the soil. To prevent this, steel pile drivers and diaphragm wall systems come into play and stabilize the ground. Tren Maya is one of Mexico's largest infrastructure projects, a huge construction process that involves laying thousands of kilometers of track. First, hydraulic excavators and bulldozers are used to clear the forest and level the ground. Crushers prepare the special ballast stones needed to stabilize the rails and spread them under the tracks with conveyor belts. In the final stage, giant rail welding machines join the steel rails together to form a continuous line, and giant roller machines compress the line one last time for precise adjustments. The Millau Viaduct is a giant structure that pushes the boundaries of engineering, built as the world's highest bridge. The construction process began with giant concrete piling machines drilling down to a depth of approximately 100 meters to create solid foundations. Then, the pre-stressed steel towers were erected with hydraulic lifting systems, and the main beams of the bridge were fixed in place. Giant cranes lifted the 2.5 kilometers long steel decks into the air with millimeter precision and placed them on the piers. The biggest challenge was the placement of the traction cables. The Pattullo Bridge Renovation Project is one of Canada's largest infrastructure transformations, transforming an aging bridge into a modern crossing using massive machinery. First, hydraulic demolition machines and cutting robots gradually dismantle the old structure, removing massive steel and concrete blocks. Then, deep foundation piling machines drove the massive steel piles that will support the new bridge into the riverbed. The Port of Miami Tunnel is a giant passage dug under the ocean and a project that pushes the limits of engineering. The construction started with the giant TBM, tunnel boring machine, Harriet, with a diameter of 12.8 meters. This giant machine worked continuously for 12 months, breaking up and removing hard rock layers and submarine mud. In the final stage, asphalt paving machines and tunnel lighting systems were put into operation, and it was open to traffic by creating a perfect connection under the sea. The Akashi Kaikyo Bridge, the longest suspension bridge in the world, is one of the greatest triumphs of Japanese engineering. The construction process began with the placement of massive steel and concrete foundations in the middle of the sea. The Caspian Islands project is a huge artificial island city built on the Caspian Sea and a construction marvel that pushes the boundaries of engineering. The Caspian Islands go down in history as one of the largest engineering projects built from scratch on water. The Ruski Bridge is one of the longest cable-stayed bridges in the world, a project that pushes the boundaries of engineering. The construction process began with hydraulic pile drivers driving steel and concrete piles into the seabed at a depth of 77 meters. The Ruski Bridge soars into the sky as one of the greatest engineering feats above the sea.